Now we're asked to solve the absolute value function by graphing and by means of graphing and also solving it algebraically. We're first going to start with graphing. Okay? So graphing. We need to do two things to start off. One, we're going to write our function as y is equal to 1/2 times the absolute value of x minus 2 minus 3. That's our first equation we're going to graph. The second one we're going to graph is now y is equal to -1. Okay? This y is equal to -1. This comes from the fact that the equation was originally equal to y was originally equal to -1. We're going to graph this now. And the intersection will be the solution. So looking at this equation, I see that 1/2 is my slope. Okay? So from my vertex, I will go up 1, and then to the right or to the left 2 to complete my graph. My vertex, on the other hand, I'm going to find from this value here and this value here. And my vertex is going to be the opposite of this value and the same of this value, such that I have a vertex of 2, -3. So I'm going to start by graphing, finding my vertex at 2, -3. And then I'm going to go up and use my slope, which says I'm going to go up 1 and to the right 2, or up, sorry, that's the wrong way to do that. I'm going to go up 1 and to the right 2, or from the origin of, or from my vertex, I'm going to go up 1 and to the left 2. From each of these points, I will either go up 1 and to the right 2, or up 1 and to the left 2. Up 1 and to the right 2, up 1 to the left 2, up 1 to the left 2, up 1 and to the left 2. At this point, I can complete my absolute value graph here and here. And it's pretty close. Then finally, I'm going to graph y equals -1. Well, this is y is equal to -1 right here. Okay? I guess I can continue this absolute value function here. And the two intersection points are solutions. So it looks to be that there's an intersection right here, which appears to be 1, 2, 3, 4, 5, 6, -1. And an intersection right about here, which appears to be -2, -1. Okay? Those would appear to be our graphing solutions there. Let's go ahead and solve it algebraically. Okay? Step 1, our goal is to isolate, again, when we go to solve this algebraically, our goal is to isolate the absolute value function. We're going to do that first by undoing the addition and subtraction of the -3 here. So we're going to add 3 from both sides, or add 3 to both sides. When I do that, I end up with 1/2 times the absolute value of x minus 2, and that's going to be equal to 2. I now have to undo my multiplication of the 1/2. It's also the same as multiplying by my reciprocal. So I'm going to multiply both sides by 2. 2 over 1 is 2. That cancels out my coefficient, leaving me with a coefficient of 1. So I end up with x minus 2. The absolute value of x minus 2 is 2 times 2, which is 4. At this point, I'm going to rewrite it as two equations. In one hand, I'm going to have x minus 2 is equal to 4. And after all, the absolute value of x minus 2 being equal to 4 means that I could be at a distance of -4 or +4 away from 0. This reflects being the positive distance away from 0. X minus 2 is equal to 4. And the other case is x minus 2 is equal to -4. Okay. At this point, it's easy to solve for x on both sides. Add 2 to both sides. In both equations, And I will come out with two answers here. X is equal to 6, which is correct. And then I will come up with over here, x is equal to -2. Since I know that y is equal to -1, I know I should have intersection points from these data at 6, -1, and also at -2, -1. There is a third way I could have solved this problem involving my calculator, and I'll go ahead and show you now. I'm going to enter in my absolute value function. I'm going to bring up my keystrokes just so you can see that as well. My function is 1/2, so I'm going to go alpha y equals, enter to create my 1/2. Then to create my absolute value function, alpha window, enter 1 for absolute value function, x minus 2, arrow key over to get out of there, minus 3. I can then go down to here, my y2 would be -1. And now I'm just going to go to my window. I'm going to do zoom 6 to graph. And I see that indeed the functions do intersect, which is good. I can then do a couple options. I can go to my graph, second graph. And I can try to find where, well, where is my y1? That would be the answer to the absolute value function equal to -1. I see at -2, both y values are -1. That's an intersection point, as predicted. And then I should be able to go to 6, 1. 6, -1, and 6, -1. So I see that's an intersection as well. All right, go ahead and do some solving of absolute values by both graphing and algebraic manipulation. Then I have this recording. Ah! Just want the slide to print.